Table 310.15b6 within the National Electrical Code, or NEC, specifically addresses residential service sizes up to 400 amps. The critical question arises if a residential service exceeds this 400 amp threshold. Can Table 310.15b6 still be applied, or does the NEC mandate a shift to the ampacity allowances outlined in Table 310.16, which generally provides for lower amperage allowances for a given conductor size? In instances involving service trenches with parallel 350 aluminum conductors installed in parallel 3-inch PVC conduits where services exceed 400 amps, the installation necessitates the use of current transformers, or CTs. The electrician's approach involves routing the parallel 350 conductors into a CT cabinet. From there, multiple load lugs would facilitate the distribution of power to 3 separate 200 amp main panels located in the basement. Hypothetically, leveraging the ampacity values for 350 aluminum conductors as presented in Table 310.15b6, one might calculate an ampacity of 300 amps per conductor. Given the parallel configuration, this would yield a total ampacity of 600 amps, satisfying the combined load requirements of the 3 200 amp main panels. However, if adherence to Table 310.16 is obligatory, the ampacity of 350 aluminum conductors is subject to different constraints. Utilizing 75°C CT lugs, the ampacity is capped at 250 amps per conductor, resulting in a total of 500 amps. Alternatively, employing 90°C CT lugs elevates the ampacity to 280 amps per conductor, culminating in a total of 560 amps. Both scenarios fall short of the required 600 amps to adequately supply the 3 200 amp main panels. In this context, the prevailing interpretation dictates that Table 310.15b6 is unsuitable for service conductors rated above 400 amps. Instead, Table 310.16 should govern the ampacity calculations for service conductors exceeding this limit. The rationale behind this regulation stems from the intended scope of Table 310.15b6, which is explicitly tailored for residential occupancies. Within the NEC, a residential occupancy is defined as a building designed for residential purposes, encompassing no more than 3 dwelling units, where the occupants are primarily private individuals. Since service sizes exceeding 400 amps are atypical for residential occupancies, the NEC mandates the application of Table 310.16 for such installations. Table 310.16 caters to other than residential occupancies, encompassing a broader spectrum of applications. Consequently, in the scenario involving the parallel 350 aluminum conductors, the electricians cannot invoke the ampacity values stipulated in Table 310.15b6 to achieve the necessary 600 amps for the 3 200 amp main panels. Instead, they must adhere to Table 310.16, which imposes an ampacity limitation of 250 amps for 350 aluminum conductors utilizing 75°C CT lugs, or 280 amps for 350 aluminum conductors utilizing 90°C CT lugs. These values fall short of the required 600 amps to adequately supply the 3 200 amp main panels. To reiterate, Table 310.15b6 of the NEC is specifically intended for residential services up to 400 amps. If a residential service exceeds this amperage, Table 310.16 becomes the governing standard for determining conductor ampacity. The definition of residential occupancy as defined in the NEC is crucial in understanding the applicability of these tables. A residential occupancy is a building designed for residential purposes, with a limited number of dwelling units, typically not more than 3. Since services larger than 400 amps are uncommon in typical residential settings, the NEC requires the use of Table 310.16, which covers occupancies other than residential. When evaluating the ampacity of conductors for services over 400 amps, the temperature rating of the termination points, such as CT lugs, must be considered. Table 310.16 provides different ampacity values based on the temperature rating of the conductor's terminations. Common temperature ratings are 75 degrees Celsius and 90 degrees Celsius. The lower of these temperature ratings typically governs the overall ampacity of the conductor. The NEC provides tables and guidelines for determining the allowable ampacity of conductors based on factors such as conductor size, insulation type, installation method, and ambient temperature. It is essential to consult these tables and guidelines to ensure compliance with the NEC and to ensure the safety and reliability of the electrical system. For services over 400 amps, the NEC requires the use of current transformers, or CTs, to measure the current flowing through the conductors. CT are used to step down the high current to a lower, more manageable level that can be measured by metering equipment. The CT are typically installed in a CT cabinet, which provides a safe and convenient location for housing the CT and their associated wiring. When installing parallel conductors, it is important to ensure that the conductors are properly sized and installed according to the NEC. Parallel conductors must be of the same material, size, and insulation type. They must also be installed in the same raceway or cable. The ampacity of parallel conductors is typically directed to account for the increased heat generated by the multiple conductors. When designing and installing electrical services, it is essential to consider the load requirements of the building or facility. The service must be sized to provide sufficient power to meet the demands of all connected loads. This includes lighting, appliances, equipment, and any other electrical devices that will be used in the building. It is also important to consider future load growth when sizing the electrical service. The service should be sized to accommodate any anticipated increases in load. The NEC provides guidelines for calculating the load requirements of buildings and facilities. These guidelines should be followed to ensure that the electrical service is properly sized. Electrical inspections play a crucial role in ensuring the safety and compliance of electrical installations. Electrical inspectors review electrical plans and inspect electrical installations to verify that they meet the requirements of the NEC and other applicable codes and standards. Electrical inspections help to identify potential hazards and ensure that electrical systems are installed safely and correctly. When planning an electrical service upgrade or installation, it is advisable to consult with a qualified electrical contractor. A qualified electrical contractor can assess the load requirements of the building or facility, design the electrical service to meet those requirements, and install the service in accordance with the NEC and other applicable codes and standards. The National Electrical Code is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. The NEC is updated every 3 years to reflect changes in technology and best practices. It is essential for electricians, electrical contractors, and electrical inspectors to stay up to date on the latest edition of the NEC. The NEC is published by the National Fire Protection Association, or NFPA. The NFPA also provides a variety of other resources related to electrical safety, including training programs, publications, and online tools. Electrical safety is of paramount importance. Electrical hazards can cause serious injuries, including electric shock, burns, and electrocution. It is essential to take precautions to avoid electrical hazards. These precautions include wearing appropriate personal protective equipment, such as gloves and safety glasses, using insulated tools, and energizing electrical circuits before working on them. It is also important to be aware of the potential hazards associated with electricity, such as overhead power lines, underground cables, and damaged electrical equipment. By following safe work practices and being aware of potential hazards, it is possible to prevent electrical accidents. The information provided here is intended for general informational purposes only and does not constitute professional electrical advice. It is essential to consult with a qualified electrical professional for specific guidance on electrical installations and safety practices. Always adhere to the NEC and other applicable codes and standards when working with electricity. Remember that working with electricity can be dangerous, and it is essential to take precautions to avoid electrical hazards. By following safe work practices and consulting with qualified professionals, you can ensure the safety and reliability of electrical systems. In the specific scenario discussed, where the electrician intends to use parallel 350 aluminum conductors to supply three 200-amp main panels. The interpretation of the NEC regarding Table 310.15b6 and Table 310.16 is crucial. Since the service exceeds 400 amps, Table 310.16 must be used to determine the allowable ampacity of the conductors. This means that the electrician cannot rely on the higher ampacity values listed in Table 310.15b6, which is specifically for residential services up to 400 amps. Instead, the electrician must use the ampacity values listed in Table 310.16, which are lower for the same conductor size. This may require the electrician to use larger conductors or to reduce the load on the service to comply with the NEC. It is also important to consider the temperature rating of the termination points, such as the CT lugs, when determining the allowable ampacity of the conductors. The ampacity values listed in Table 310.16 are based on specific temperature ratings, and the actual ampacity of the conductors may be lower if the termination points have a lower temperature rating. In summary, when dealing with residential services that exceed 400 amps, it is essential to use Table 310.16 to determine the allowable ampacity of the conductors. It is also important to consider the temperature rating of the termination points and to ensure that the service is properly sized to meet the load requirements of the building. Consulting with a qualified electrical contractor is recommended to ensure compliance with the NEC and to ensure the safety and reliability of the electrical system. This approach ensures adherence to the NEC guidelines and promotes the safety and reliability of the electrical installation. Firstly, Table 310.15b6 is specifically for dwelling units and associated loads, and it's not applicable when the overall service size exceeds 400 amps. Secondly, Table 310.16 provides ampacity ratings for conductors in various conditions, including those used in services over 400 amps, and it must be used in this case. Thirdly, the definition of residential occupancy is key here, emphasizing buildings with no more than 3 dwelling units occupied primarily by private individuals. Fourthly, if the service exceeds 400 amps, it's no longer considered a typical residential service, and Table 310.16 must be followed. Fifthly, the electrician must carefully consider the temperature rating of the terminals, such as the CT lugs, and use the appropriate ampacity values from Table 310.16. Sixthly, the use of parallel conductors requires careful attention to ensure they are of the same material size and insulation type and are installed in the same raceway. Seventhly, the ampacity of parallel conductors may need to be rated based on the number of conductors in the raceway and the ambient temperature. Eighthly, a qualified electrical contractor should be consulted to ensure compliance with the NEC and to ensure the safety and reliability of the electrical system. Ninthly, electrical inspections are essential to verify that the installation meets the requirements of the NEC and other applicable codes and standards. Tenthly, safety precautions must be taken when working with electricity, including wearing appropriate personal protective equipment and energizing circuits before working on them.